Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the overall structure. The compound has 3 ring systems, a decalin core, 2 fused cyclohexane rings, a cyclopentane ring attached via a CH2 group, and an ester side chain containing a 2-methylbutanol group. Moving on to the next step. Analyze the decalin ring system for chiral centers. The 2 ring junction carbons of the decalin, C4A and C8, are in naphthalene numbering, each bear 2 ring carbons, 1H, and distinct substituents. Both ring junction carbons are chiral centers. That gives 2 chiral centers. The carbon on the left ring bearing the OC is equal to O, ester oxygen group. It is attached to the ring junction carbon, another ring carbon, H, and the ester oxygen, 4 different groups, so this is a chiral center. That gives 1 more is equal to 3 total so far. The carbon on the left ring bearing the methyl group, it is attached to 2 different ring carbons. The chain is asymmetric due to the rest of the ring and substituents, H, H, and methyl weight. If it has 2 H's, it is not chiral. Re-examining, the methyl-bearing carbon on the cyclohexane ring has CH3, H, and 2 ring carbons. If the 2 ring carbons lead to different environments, which they do given the asymmetry of the ring, this carbon bears 4 different groups, CH3, H, ring C going one direction, ring C going other direction. This is a chiral center. That gives 1 more is equal to 4 total. The carbon bearing the CH2 cyclopentyl group on the right ring, it has H, CH2 cyclopentyl, and 2 ring carbons in different environments. This is a chiral center. That gives 1 more is equal to 5 total. Moving on to the next step. Analyze the ester acid portion, to methylbutanol group, CH3CH2CH, CH3, C, is equal to O, O. The carbon alpha to the carbonyl, CH3CH2CH, CH3, dash, bears ethyl, methyl, H, and C, is equal to O, O, 4 different groups. This is a chiral center. That gives 1 more is equal to 6 total. And for the final step, analyze the cyclopentane ring. The cyclopentane is attached via a CH2 linker. The carbon on the cyclopentane ring bearing the CH2 group, it has CH2 decalin, H, and 2 ring carbons. If the cyclopentane ring carbons on either side are equivalent, symmetric cyclopentane with only this one substituent, then the 2 ring carbon substituents are mirror images of each other. Actually, in a monosubstituted cyclopentane, the carbon bearing the substituent has H, CH2 group, and 2 CH2CH2 ring portions that are identical, so it is not a chiral center. Total chiral centers is equal to 2 ring junctions plus 1 OC is equal to O bearing carbon plus 1 methyl bearing ring carbon plus 1 CH2 cyclopentyl bearing carbon plus 1 alpha carbon of acid is equal to 6. Why other options fail? A. 4 undercounts several stereocenters in the decalin and side chain. B. 5 misses 1 stereocenter. D. 7 overcounts, possibly erroneously counting the cyclopentane attachment carbon. Therefore, the correct answer is C. Therefore, the correct answer is option C.